Hello everyone, welcome to the new video of Automata and Computability. In this video, we are going to design a DFA that accepts all the binary strings having an even number of zeros or an odd number of ones. Alright, so let's design it. But before designing it, we need to know what can be the possible cases or possible scenarios, right? So you can see that in our question it has been asked that the number of zeros have to be even. So here there can be two possible option. One is even number of 0 or odd number of 0. So there is two option, right? And similarly for 1 then there can be two possible option again, right? Even number of 1 or odd number of 1. So we can have total 2 into 2, which is 4 possible combination. One is even number of 0, even 0, odd 1, then even 0, even 1, and similarly odd 0, odd 1 and odd 0, even 1, right? So this can be the possible 4 option. So let's design the DFA. So we can detect that from, as there is 4 possible option or possible scenarios, so we will have 4 different states, right? So there will be 4 states. So there will be 4 states. So this one is even 0, and even 1, even 0, even 1, and similarly this will be even 0, odd 1, and then this can be odd 0, even 1, and this can be odd 0, odd 1. All right, okay. So now what will be the final states? As it's odd, so if the state has even 0 or odd 1, then that will be a final state. So this state has both even 0, this state has even 0, so this will be our one of our final state. Similarly this has both even 0 and odd 1, so it will also be a final state. And this is odd 0 and even 1, so this won't be a final state, right? Because we need to have either even 0 or odd 1, but this doesn't satisfy any of the condition, so this won't be our final state. But this satisfied the odd number of 1 condition, so this will again be a final state. So there will be 3 final states. And what will be the start state? That will be even 0, even 1. Why? Because at the very beginning, when we do not have any 0 or 1, then the number of 0 will be 0, right? And similarly the number of 1 will be again 0, right? This is when there is no input, right? Before getting any input, the number of zeros will be 0 and the number of ones will be 0, and we know that 0 is an even number, right? So that's why the case where both 0 and 1 is even will be our start state. Okay, so now from even 0, in this state the number of 0 is even, right? So from this state if we get another 0, then the number of 0 will become odd, right? Because even plus 1 equal to odd, right? So from this state if we get another 0, then the number of zeros will be odd. but as we got 0, so the number of 1 is unchanged, right? So we will go to odd number of 0 and even number of 1, right? Because we got 0, so the number of 1 is unchanged, which is even. So we will go to this state, and if from this state we get 1, then the number of 0 will be unchanged, but the number of 1 will become odd, right? Because at first it was even number of 1, and then we got the new one, right? So the number of 1 will become odd. Okay, now from this state, here the even 0 and odd 1, here the number of 0 is even, right? So if we get another 0, that will become odd 0, right? So we will go to the odd 0 and odd 1, and from this even 0 and odd 1, if we get another 1, then the number of 1 will become even, right? And the number of 0 is unchanged, which was even, because we got 1. So we will go to even 0 even 1 state. Okay, now from odd 0 even 1, if we get 0, then the number of 0 will become again even, right? So we will go to even 0 even 1, because the number of 1 is not changed. But if we get 1, then the number of zeros will remain odd, but the number of 1 will become odd, right? Because the number of 1 is currently even, and then we got the new one, so the number of 1 will become odd. So we will go to this odd even odd 1, and from this state, from odd even odd 1, odd 0 odd 1, if we get a 0, then the number of 0 will become even. So we will go to even 0 odd 1. But if we get 1 from this state, then the number of 0 will remain odd, but the number of 1 will become 1, right? So we will go back to this state. So this will be our DFA. That's it. Thank you.